in this example, we're going to take the sum of all the elements of a 2D array. Okay? So, just to do a very quick example of what I mean, let's say we're given the 2D array of 1.0, 2.0, 3.0, 4.0. Okay? So, we know that this is just a 2D array where there are 2 rows, 2 columns, and we're just going to return the sum of all the elements, so that would be 10.0. Okay? And it doesn't matter how it's arranged, so we could have like 1.0, 2.0, 3.0 with only 3 rows and 1 column. So this is really just synonymous with like a one-dimensional array, but we could do that because each one of these is just a singleton, basically an array of one element. And if we have an array that looks like this, then we'd have like 1.0, 2.0, 3.0. This is just an array with 1 row and 3 columns. Okay? But again, that's just a 1D array. But it's something you need to consider when you're writing methods that operate over 2 dimensions. Okay? And of course, this works when the dimensions are not the same. So 1.0, 2.0, 3.0, 4.0, 5.0, 6.0. This would of course return 6 plus 15, so 21. And if we flip this to be like 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, these would all return the same thing. Or these two would return the same thing of the same sum of 21. Okay? So fortunately in this case, the order that we traverse this in doesn't matter because we're just computing the sum of the elements. So addition is both associative and commutative, so it doesn't matter what order we collect them in. Okay? And one thing I will say is that an array that contains an array that is just empty will sum to 0, which that should make sense. Okay? So you could return null in this case, or well, not null because it's a double, but you could return something. You could do something different depending on how you want to consider a null array. And when we talk about the rest of the collections API in a couple of videos, we'll talk about one of those possible solutions. Okay? So, how are we going to do this? Well, we're probably going to keep track of a sum so far, and that's equal to 0. That should be a double. And then we're going to return sum so far. So, in here, again, we're going to do some work over the array. So, how are we going to do this? Well, this is where multiple for loops come into play. So, we want one for loop that's going to control the traversal from through the columns and over the rows. Okay, so one for loop, which is going to be the outer for loop for us. We're going to say that that's going to traverse over the rows. Okay, so I is going to take on values from. Let's say we have a 2 by 3 array. So 2 rows. Let's do 3 by 4. So 3 rows, 4 columns. Okay, so what is this going to look like? Well, I is going to take on values from 0 to 1 to 2. And our little, in our diagram here, well, let's take a look at the one we did in the previous video. So if we're doing this example, then the number of rows we're going to traverse over is, well, 3. But it's going to take on the values 0, 1, and 2. Okay? We're going to have an inner for loop that gets us this value, this value, this value, and this value. Okay? So the inner for loop will control what element we're actually on, whereas the outer loop will control which row we're on. And remember, that's called row major order. If we were doing it the reverse and we were saying that we want to see this element, and this element, where the inner loop controls what element we're on and the outer loop controls what column we're on, then that would be column major order. And I strongly encourage you to take this code and rewrite it. It wouldn't be very hard to see what the difference would look like. Okay? So we're going to have an inner for loop that's going to say int j is equal to 0. J is less than what? We want to get the number of columns in our array. So how do we do that? Well, we can do a at 0 dot length j++, but you can also just do a at I, okay? Because a at I will always be between 0 and 2, so, or 0, 1, and 2 for this example, so, or not between, it will be exactly one of those three values. And because of that, we're always going to get the same thing for the length of each inner array. Okay? So now all we have to do is, how do we get the current element? Well, we get the current element by doing a at I, j. Okay? And then we're just going to take that and add that into our sum so far. Okay? So that's really all you have to do. I mean, this particular example is not very hard. The book has many cases of using 2D arrays, and I strongly encourage you to look through those before moving any further, because some problems will inevitably require the use of a 2D array, and you absolutely need to know two things. You need to know three. One, how for loops work, so how a normal for loop works and how a nested for loop interplays with that. Two, how a one-dimensional array works. Three, how multiple dimensional arrays work. Okay? So get some practice with that.